Hello, this is Dr. Hanaa Assil, and this is paper 2C of January 2023 in the Pearson Edexcel IGCSE. So let's take a look at these questions. The first question says, the diagram shows the electronic configuration of an atom of an element. Complete the table by giving the missing information. So you have the electronic configuration of an atom, and he's saying, name the part of this atom labeled A. Of course, A is the central part of the atom, and you should know that the central part of the atom is called the nucleus. Number of the group that contains this element. How do we determine the number of the group? We look at the outer shell, the very last outer shell has how many electrons? You can see that it has 2 electrons. That means this element is in group 2. Number of the period that contains this element. How do we get the number of the period? You should know that the number of the period is the same as the number of energy levels, the number of shells. So we have 3 shells or 3 energy levels. That means this atom is in period 3. Then he gives a table, and he says the table gives information about 4 different species. Give the mass number of W. How do we get mass number? You should know. Mass number is the number of protons plus neutrons. So we have 2 protons, 2 neutrons. That means the mass number of this atom is 4. Give a reason why X has a 3+ charge. So where is X? You can see that X has 3 protons more than the number of electrons, and protons are positively charged. So if it has 3 more protons than electrons, then it has 3 more positive charges. Explain why Y and Z are isotopes of the same element. Where is Y and Z? We can see that Y and Z have the same number of protons but different number of neutrons. Remember, this is the definition of isotopes. Isotopes are atoms of the same element having the same number of protons but different number of neutrons. Question 2 says the table shows properties of 4 substances A, B, C, and D. And he's saying use information from the table to identify these substances. So he's saying which substance could be a metal. How do I know which one is a metal? You should realize that the metal is the one that conducts electricity when solid. So which one conducts electricity when solid? That is B. Anything that's not a metal would not conduct electricity when solid. It would conduct electricity when molten or in solution, of course, except graphite. Which substance could be diamond? Which one is diamond? First of all, diamond must have high melting point, high boiling point. And diamond would not conduct electricity, whether solid or molten. So the one that applies to all of this is D. High melting point, high boiling point, does not conduct electricity when solid and does not conduct electricity when molten. Which substance is a gas at 600 degrees Celsius? Well, to be a gas at 600 degrees Celsius, that means its boiling point is below 600. The boiling point is less than 600. So which one has boiling point less than 600? That's C. And that means by the time it reaches 600, then the boiling point is 573. So it will boil and be a gas at 600 degrees Celsius. One of the substances in the table is a compound with this formula. Give the number of different elements in this compound. How many different elements do we have in this compound? We have carbon, hydrogen, nitrogen, oxygen, sulfur. So we have a total of 5 different elements. Then he says determine the number of atoms in a molecule, the total number of atoms. So you need to add all the atoms. How many atoms do we have? We have 10 carbons, 16 hydrogens, 2 nitrogens, 3 oxygens, and 1 sulfur. So the total number of atoms is 32. Can you see that? This question is about soluble salts and insoluble salts. Which pair of solutions produces an insoluble salt when mixed? You have to remember which compounds are soluble and which ones are not soluble. Remember, sodium salts are all soluble. Potassium salts are all soluble. Nitrates are all soluble. The one that is not soluble in this is if I react potassium carbonate with calcium nitrate. This will give what? This will give potassium nitrate, which is soluble, but it will also give calcium carbonate, and calcium carbonate is an insoluble salt. So again, remember, sodium anything, potassium anything, anything nitrate, ammonium anything, all of these salts are soluble. Calcium carbonate is not soluble. When solutions of lead nitrate and sodium sulfate are mixed, one product is solid lead sulfate. So he gives you the equation. Reaction of lead nitrate with sodium sulfate will give lead sulfate solid. Describe how a pure dry sample of solid lead sulfate can be obtained from the mixture. So he already added lead nitrate to sodium sulfate. He got a solid, that means he got a precipitate of lead sulfate. What should he do to separate that and get a dry sample of that solid? Well, if we have a precipitate in a mixture, to separate it, we need to do filtration. So filter the mixture through filter paper and funnel. If we filter the mixture like this, then the lead sulfate which we want is the residue in the funnel, in the filter paper. So I already separated the lead sulfate as a solid in the filter paper. What should we do next? Remember, we shouldn't do any crystallization of any kind. I already have my required solid in the funnel. All I need to do is wash the residue with a few drops of distilled water, dry between filter papers. This is what we call precipitation reaction, and this is the method to obtain an insoluble salt from soluble reactants. So both lead nitrate and sodium sulfate are soluble. I add them together, they give me a precipitate, then we just filter and wash and dry the residue. The table gives the solubility of a salt in water at 6 different temperatures. Plot the points on the grid and draw a curve of best fit. You should know how to plot. Please practice plotting. The examiner follows each point to make sure that your points are correct. Then when we come, of course, when we plot them, we have to plot with small x's or a small circle, a dot with a small circle around it. Please do not plot with just dots. It has to be small x's. Then you join. So this is a curve of best fit. So the curve should pass through as many of the points as possible. Then he says a saturated solution of the salt in 100 grams of water is cooled from 90 to 30 degrees Celsius. Use your graph to determine the mass of salt that will crystallize. Remember, this is a graph of what? This is a graph of solubility in gram per 100 gram of water. So at each temperature, he's showing you how much of the solid will dissolve in 100 grams of water. Now, what is he saying? He's saying we cooled the solution from 90 degrees Celsius to 30 degrees Celsius. Where is 90? 90 At 90 degrees Celsius, 124 grams were dissolved. Now, if I cool it to 30 degrees Celsius, then only 44 grams will dissolve, and that means the rest will form crystals. So the rest, he wants how much of the salt will crystallize. I will get 80 grams of the salt forming out as crystals. Fractional distillation is used to separate crude oil into fractions. The diagram shows a fractionating column and the fractions obtained from crude oil. Describe how crude oil is separated into fractions in the fractionating column. So how do we do fractional distillation of crude oil, or what is happening to the crude oil? Remember that crude oil is a mixture of liquids. And what we do is the crude oil is heated and vaporized. The vapors rise in the fractionating column and are cooled and condensed at different boiling points. The fractions collected at the top have lower boiling points, lower number of carbons. They're also more flammable, less viscous, and so on. So this is what happens in the fractionating column. Give a use for kerosene and a use for bitumen. Remember, you are required to know the order in which the substances come out from the fractionating column and the use for each one. What do we use kerosene for? You can say jet fuel or fuel for airplanes, and you can also say it is used for heating and cooking. Bitumen is used for making roads or surfacing roads. Some fractions obtained from crude oil are cracked to form alkenes. Describe what is meant by cracking. What is meant by cracking? You should remember that cracking means I have long chain hydrocarbons and we break them into shorter chains. So cracking is the breakdown of long chain hydrocarbons into shorter chains. And we said usually when we do that, what we get is an alkene and an alkane, or an alkene and hydrogen. And the alkene is usually ethene, or in most cases ethene. Ethene is obtained by cracking. This is the displayed formula of ethene. Explain why ethene is described as unsaturated hydrocarbon. So you need to mention, this has 3 words. You need to mention why we say it's unsaturated, why we say it's a hydrocarbon. What does unsaturated mean? Remember, unsaturated because it has C double bond C. Or if you want to write it in words, it has double bonds between carbon atoms. Don't just say double bonds. It has double bond between carbon atoms, or just write it as it is written here, C double bond C. Why do we say it's a hydrocarbon? Because it has carbon and hydrogen only. Please do not forget only, because all organic compounds have carbon and hydrogen. But if it has carbon and hydrogen only, it's a hydrocarbon. Describe a test to show that ethene is unsaturated. Do you remember what was the test for unsaturation, or the test for alkenes? The test for alkenes was what? Add bromine water, it decolorizes, or it turns colorless, or it changes from orange to colorless. So that is the test for alkenes. This question is about metals. Explain why metals are malleable. Why are metals malleable? Remember, when we talked about structure of a metal, we said metals are made of what? Regular rows of positive ions surrounded by a sea of delocalized electrons. It's a solid, so it has regular rows like any solid. The atoms have 1 or 2 or 3 electrons in its outermost shell. It doesn't want them, so we say they are regular rows of positive ions because the electrons are delocalized. They're a bit further away. So why are metals malleable? You should remember this is because the layers of positive ions can slide over each other when heated or hammered. Remember here, there are layers of positive ions and they can slide over each other, not because of weak attraction forces between the layers. Remember when we talk about graphite, we say graphite is soft because it has weak attraction forces between the layers. So the layers slide over each other. Here, these are metals, so we just say layers of positive ions can slide over each other when heated or hammered. Okay? Sodium metal is extracted by the electrolysis of molten sodium chloride. Sodium metal forms at the negative electrode and chlorine gas forms at the positive electrode. The diagram represents this electrolysis. So this is supposed to be electrolysis of molten sodium chloride. Explain why molten sodium chloride conducts electricity. We said, why does it have to be molten? Because when it is molten, the ions are free to move. So ions are free to move when molten. If he says, why doesn't it conduct electricity when it's solid? That's because when it's solid, the ions are fixed or they are not free to move. Explain how sodium metal forms at the negative electrode. Okay. What is happening here? Remember that sodium ions are positively charged. So it is Na+. Now, it will be attracted to the negative electrode. So remember that sodium ions are positively charged. They are attracted to the negative electrodes to do what? To gain electrons and become sodium atoms. This is how the metal forms at the negative electrode. Write an ionic half equation for the formation of chlorine gas at the positive electrode. So if we have molten sodium chloride, you should know that what we have in solution is the chloride ions. So the chloride ions will go to the positive and give electrons and become chlorine atoms, but chlorine is diatomic, so we form Cl2. This needs to be balanced. When we balance these equations, we balance the atoms and we balance the charge. So if I have 2 chlorines after the arrow, I need 2 chlorines before the arrow. So I put 2 before the chloride. That means now I have 2 negatives before the arrow. I need 2 negatives after the arrow. So that is 2 in front of the electron. Give a reason why sodium metal does not form in the electrolysis of aqueous solution of sodium chloride. Previously, he was talking about molten sodium chloride, and you should know that when we have molten, that means we just heated it until it melted. So we have only sodium ions and chloride ions in solution. So the sodium reacts at the cathode and forms sodium metal. The chloride reacts at the anode and forms chlorine gas. So that was molten. But now he's saying, what about if we're talking about aqueous solution of sodium chloride? Remember that when we have an aqueous solution, this means that now, in addition to the Na plus and Cl minus, we also have the ions from water. This is a solution, so it's dissolved in water, so we also have H plus and OH minus ions. Now at the cathode, we have a choice. Which one is going to react, the Na plus or the H plus? So he's saying, give a reason why sodium metal does not form. This is because sodium is more reactive than hydrogen. We said the one that is less reactive in the electrochemical series, that's the one that reacts in electrolysis. So sodium is more reactive as a metal, so it will not react here if there is another choice. So hydrogen is the one that will react, the H plus is the one that will take electrons and form hydrogen gas instead of forming sodium. Copper can be produced by reacting an oxide of copper with methane. So he has oxide of copper and he's passing methane gas. The oxide of copper is heated until the reaction is complete. The table shows the results. So he weighed the empty weighing boat, that's the container in which he has the solid. Then he weighed the weighing boat plus oxide of copper and the weighing boat plus the copper alone at the end of the reaction. And he's saying use the results to show that this oxide has the empirical formula CuO. Okay, what are we supposed to do? In order to get the empirical formula, we need to get the mass of each one. So what is the mass of copper and what is the mass of the copper oxide? How do we get mass of copper? We already have the mass of the empty boat or the empty container. Now, if I subtract that from the boat plus copper, then I will get mass of copper. So the mass of copper is the boat plus copper minus the boat alone. That gives me mass of copper. Mass of oxygen. How do we get mass of oxygen? Well, we have mass of boat and oxide of copper and boat plus copper alone. So if I subtract these two, then I will get the mass of oxygen. So now I have a mass for copper and a mass for oxygen, and we calculate the empirical formula in the usual way. How do we do empirical formula? The first thing you do is divide by the atomic mass. He already gives me the atomic mass there, or if he doesn't give it to me, I get it from the periodic table. Copper, I divide by 63.5, oxygen I divide by 16, and I get these numbers. Then we're supposed to divide by the smallest in order to simplify the ratios. Both of them are the same. That means it's a ratio of 1 to 1, and that means that my formula is CuO. When ethanoic acid reacts with ethanol in the presence of concentrated sulfuric acid, one of the products is ester A. Remember, acid plus alcohol will give ester plus water. Now, draw a circle around the functional group in ethanoic acid. Which part of ethanoic acid indicates that it is an acid? Remember, functional group is the part of the molecule that identifies the homologous series it belongs to. So if we're saying this is an acid, we're saying it's an acid because it has what? You need to put a circle around this. C, double bond O, single bond OH. That is the part that identifies that this is an organic or a carboxylic acid. Give the displayed formula of the ester. How do we draw ester? Remember, when we want to draw the ester, we draw the acid first and then the alcohol. The acid, you remove the OH, so I end up with that first part of ethanoic acid till C double bond O. And then I add the part from the ethanol without the H. So I remove OH from acid, H from alcohol. So that's why the other product is water. And this would be the displayed formula of the ester. How do we name this ester? Well, it was from which alcohol? Ethanol. That means the name starts with ethyl something. Now, the acid was ethanoic acid. That means the ester would be ethyl ethanoate. The ethyl part was from the name of the alcohol. The OH part was from the name of the acid. Reaction mixture is kept in a sealed container until dynamic equilibrium is reached. Remember, that equation was a reversible equation. What is meant by the term dynamic equilibrium? We said a reversible reaction is one in which it goes forward and backward. It's a reaction that goes both forward and backward. And we said it keeps going forward and backward until it reaches dynamic equilibrium. What is meant by dynamic equilibrium? That the rate of forward reaction equals the rate of backward reaction, or both forward and backward reactions occur at the same rate, and concentration of reactants and products remain constant. Don't say the same. They're not the same. They are constant. That means the concentration of reactants remain constant, and the concentration of products remain constant. They don't change, not that they are equal or that they're the same. So remember that these are the two conditions for dynamic equilibrium. Rate of forward reaction equals rate of backward reaction, and concentration of reactants and products remain constant. During the reaction, the number of moles of ethanoic acid in the reaction mixture decreases. Of course, because ethanoic acid is reactive. But the number of moles of concentrated sulfuric acid does not change. So they have ethanoic acid and ethanol and sulfuric acid, but the sulfuric acid does not change. Give a reason why the number of moles of concentrated sulfuric acid does not change. We said if we have something in a reaction that does not change and we just put it there, that means it's a catalyst. A catalyst is a substance that speeds up the reaction without being changed. So the reason we're using concentrated sulfuric acid is that it is a catalyst. And a catalyst is not used up, or it's not changed during the reaction. A student does a titration to find the accurate volume of sodium hydroxide solution needed for complete neutralization. So he had acid in the flask and he wants to titrate it with sodium hydroxide. The student starts by using a pipette to transfer 25 centimeter cubed of the reaction mixture to a conical flask. Describe how the student should complete the titration. Okay, so he's given you 6 marks to explain exactly how to do titration. So how do we do titration? We should add. He already has 25 centimeter cubed in a conical flask of the acid. So he already has the acid in a conical flask. So the next thing would be add 3 drops of an indicator. It could be methyl orange or phenolphthalein. If we add methyl orange to something that is acidic, then the solution turns red. Then you want to explain in detail. So tell him, wash a burette with the solution that we're going to fill with. So we're going to wash the burette with sodium hydroxide solution. And then fill the burette with the sodium hydroxide solution. Record the initial volume of sodium hydroxide. Add sodium hydroxide from the burette until the red color turns to orange. Record the final volume of sodium hydroxide to determine the volume needed for neutralization. Then you could say repeat to obtain concordant results. So this is how we do exactly. You could also mention the fact that we swirl the conical flask during titration. The fact that when we come near the end point, we should add drop by drop, things like that. This question is about hydrazine. This is the displayed formula for a molecule of hydrazine, and he's saying complete the dot and cross diagram for hydrazine. So obviously nitrogen, if you look at the periodic table, it's in group 5. It needs 3 more electrons. It has 5 electrons in its outermost shell, so it needs 3. So it's going to share 1 with the hydrogens and with the nitrogen next to it. It still has the rest of the 5, so don't forget the lone pair of electrons, the 2 electrons up there that are not being shared, to complete the 5 electrons of the nitrogen. Okay, so this should be the dot and cross diagram that you should be able to draw. 1 pair of electrons being shared with each hydrogen and with the neighboring nitrogen. And then we have extra 2 electrons for each nitrogen because they used up only 3 of their electrons, so they still have 2 of the 5 as lone pairs not involved in sharing. This is the question for decomposition of hydrazine. So he has this equation and he drew it all out for you. So he drew out all the bonds very clear so that there is no confusion. And he's given you a table with bond energies, and basically we're trying to get delta H. So this is the bonds in detail displayed form so that you can see them. And he's saying use the data in the table to calculate the total energy needed to break all the bonds in the reactants. Where are the reactants? Before the arrow. Where are the bonds? We have 3 N bonds. Can you see that? And we have, can you see how many NH bonds? So we have 3 NN bonds, so 3 times 158. Plus, we have 3 times 12 NH bonds. Each of them needs 391. So the total amount of energy needed to break all the bonds in the reactants is 5,166 kilojoule per mole. Then use the data in the table to calculate the total energy released when all the bonds in the products are formed. Remember, when we form bonds in the products, they give out energy. So when we're breaking bonds in the reactants, we need to give it energy. When bonds are formed in the products, they give out energy. So what kind of bonds do we have formed in the products? We have the NH bonds. How many NH bonds do I have? I have 3 for each NH3. I have 4 of them, so 3 times 4. And he tells me that the NH bond is 391, plus the N triple bond N, which is for 945. So the total of all that is 5,637. So when he says calculate the delta H, how do we calculate the delta H? It is the energy needed to break all the bonds minus the energy released when the bonds are formed in the product. So it's reactants minus products. Reactants minus products in this case comes out to be a negative value. Remember, when delta H is negative, that means this reaction is what? It's exothermic. So explain in terms of bonds broken and bonds made why this reaction is exothermic. Remember, if I have any reaction, we need to give it energy to break the bonds in the reactants. And then it releases energy when bonds are formed in the products. And the difference between this is the delta H. So why are we saying this is exothermic? Because energy is given out. Now, that means that the energy needed to break the bonds in the reactants is less than the energy released when bonds are formed in products. Remember, bond breaking is endothermic, bond formation is exothermic. So when we break bonds before the arrow, that is a positive amount of energy being added, endothermic. When we form bonds in the products, that is an exothermic reaction, it releases energy, and the difference between them is the delta H. So if overall it's exo, that means that the energy given in to break the bonds in the reactants is less than the energy released when bonds are formed in the product. A sample of hydrazine is completely decomposed. This is the equation for the decomposition. The products of the decomposition are bubbled through 1,100 centimeter cubed of water. The ammonia completely dissolves. So ammonia forms ammonia solution. But nitrogen is insoluble. The nitrogen that is left has a volume of 1,570 centimeter cubed. Calculate the concentration of the ammonia solution. Oh, so he's telling me that I end up with ammonia and nitrogen. But the ammonia will dissolve in water, the nitrogen will not. And he gives me the volume of nitrogen. If he gives me the volume of nitrogen, I can get what? I can get the number of moles of nitrogen. You should know that number of moles of a gas is volume over 24, or if we use the volume in centimeter cubed, then it is divided by 1,000. You remember that? So if we put the volume in decimeter cubed, you divide by 24. If we put it in centimeter cubed, you divide by 24 times 1,000, so 24,000. So this gives me the number of moles of nitrogen. Now I can go back to the equation on top and relate the number of moles of nitrogen to the number of moles of ammonia. You can see that the equation says if I have 4 moles of ammonia, I have 1 mole of nitrogen. That means the number of moles of ammonia should be 4 times that of nitrogen. So I can get number of moles of ammonia. It is 4 times what I got for nitrogen. Now I have number of moles of ammonia. What does he want? He wants concentration. Well, number of moles is concentration times volume. And that means concentration is number of moles over volume. The number of moles that I calculated over the volume of water, we said we dissolved the ammonia in 1,100 centimeter cubed of water. So divide that by 1,000 in order to use it in decimeter cubed. That gives me the concentration in mole per decimeter cubed. Please notice, he says, give your answer to what? To 3 significant figures. So 0.238 has to be 0.238. You cannot say 0.24. You know how to count the number of significant figures. Okay, in this case, I have 0.238 is in 3 significant figures. Okay, and that was the end of this paper. I hope you understood all of this and you found it useful. Please share with others and keep listening to the videos. Thank you.